Hello, everyone. I'm very happy to take part in this really great virtual event by Check Point, and I would like also to thank you. Thank you for coming and joining us. My name is Itzhak Fegelevich, and I'm the product manager who leads IoT cybersecurity solutions at Check Point. Now, I'm sure that all of you will agree with me that IoT is one of the biggest trends in the market today. There is a huge buzz around this topic, and I'm sure that many of you have noticed the huge numbers of IoT devices that we are expecting to see in the coming years. Numbers that are ranging between 20 billion IoT devices up to 50 billion IoT devices, in some reports even up to 80 billion IoT devices. Now, those are of course very impressive and very important numbers. But more important is the fact that already today, we are facing a huge number of IoT devices all around us. And already today, you are facing a huge number of IoT devices that are connected to your networks. Now, one of the first questions I'm always asking when meeting with a new customer is, do you really know how many IoT devices are connected to your network today? Those devices are part of your network. They are connected to your network. So how many devices do you have inside your network today? And the answer is always no. I don't know. Now, think about it. You reach into work in the morning and enter the parking of your building with your car. Probably you will notice a license plate camera. This is a connected device. It is connected to your network. It automatically identifies the license plate of your car, communicate with a server that is also connected to the network that holds a list of the authorized employees who are authorized to enter this parking of this building. Now, you enter into the building, you go into the lobby, and you will notice IoT devices all over. We have badge readers and smart doors, lots of surveillance cameras. All of those devices are connected already today to your network. You're going into the elevator, going up and entering your office. And also here, you will notice IoT devices all over. We have smart sensors, we have motion detectors, printers, IP phones, faxes, huge number of IoT devices that already today connected to your network. Our researchers found out that in a typical enterprise of 5,000 employees, you will find around 20,000 IoT devices. 20,000 of IoT devices, smart office, smart building devices that are connected to your network today. In a typical hospital of 500 beds, you will find around 10,000 IoT devices. Most of them, by the way, will be connected medical devices. We have MRI machines, CT devices, infusion pumps, patient monitors, but not only. We have also general IoT devices. We have gas systems, water systems. All of those devices are connected today to the hospital network. And in a typical factory of 2,000 workers, you will find around 5,000 industrial IoT devices. We have different controllers, SCADA systems, we have PLC devices. All of those devices are connected today to the factory network. Now, how are all of those devices are connected to your network? What protocols are they using? What traffic flowing between the different IoT devices inside your network? From your point of view, the security manager, the IT manager, the network manager, those are non-trivial devices that are connected to your network. Many of those devices have their own and unique characteristics, such as the device functionality. It can be the device operating system. You have all of those crazy IoT and OT protocols, SCADA, Modbus, DryNet, HL7, DICOM, protocols that probably you are not so familiar with. And the most disturbing thing is that many of those devices are unmanaged devices, meaning that even so that those devices are connected to your network, you don't have any way to control them, you don't have any way to view them, and you don't have any way to set a policy for those devices, telling what they can do and what they cannot do inside your network. Now, many of those devices are also connected to the external internet. It can be because of maintenance issues. We would like to enable the different vendors of the different IoT devices to be able to access those devices, to update and upgrade them, making sure they're always running the latest software version. It can be because we would like to enable access to remote users, specifically during these COVID-19 days where many of us are working from home. Or it might be because we would like to enable access to third-party service providers who are managing those devices for us. So many of those devices are connected to the external internet, and the attackers using standard scanning tools can find those devices and get access to them. Now, the attackers, the bad actors, can also access those devices directly. Think about all the visitors, technicians, everyone who can walk freely through your facility, the employees. Do they have access to some of those IoT devices? Can they go and connect to some of those devices, let's say using a USB port or maybe an Ethernet port? How many of those devices are connected to open Wi-Fi networks? And once you've managed to get an access to an IoT device, it is quite easy to hack into the IoT device itself. Many of those devices don't even have basic security capabilities. Many of those devices are based on simple microcontrollers that don't have enough memory. Many of those devices are based on outdated software and legacy operating systems. And many of those devices are based on default passwords. 1234, 8888. Those devices come out of the box with a default password. Someone taking this device, install it inside the network, and never make sure to change the default password of this device. Have anyone here ever changed a default password in one of the surveillance cameras that you have inside your building? Probably not. We are talking about thousands of devices that you need to do that for. Now, we have limitations that preventing us from going and fixing those issues. Limitations such as physical access devices that need to work 24/7. We have different certifications, we have regulations. And in many cases, as I said, those devices are just unmanaged devices. We don't have any way to control those devices and to change the software inside those devices. Now, the attackers, they know that, and they're using those devices. They're using those devices in two ways. The first way is hacking into the IoT devices themselves and then manipulating those devices, and by doing so, damaging the operation of your business. It might be, for an example, a medical device in the hospital, and the attackers can manipulate this device and by doing so, even to kill someone. It can be an industrial device in the factory. Manipulating such a device can force the factory to shut down the entire production line. Or it can be just a simple IoT device like a security camera inside your building, and the attackers can take control, can take over this camera to see what it is, maybe to turn it into a bot in a botnet attack, or maybe to use it for crypto mining. The second way the attackers using those devices is as backdoor to your network. Because in many cases, those devices, as I said, are connected to the external internet, but also in many cases, they are connected insecurely to the external internet. It can be because of misdesign, misconfiguration. We don't always have the right knowledge about how to connect those devices to the external internet. So the attackers can get quite easily access to those devices, hack into them, and through those devices to get into your network. Last year, Microsoft published that they found out that a hackers group from Russia, known as APT28, are using those exactly IoT devices. They're using printers and IP phones that are based on default passwords in order to get into the enterprises' networks. They actually use those devices to get into the network, to scan the network for other devices that might be more attractive to get into them. I'm sure that all of you are familiar with the Mirai Attack. Back in 2016, targeting hundreds of thousands of IoT devices, many consumer devices, creating a huge DDoS attack. But since then, since 2016, we keep seeing every month new variants of Mirai Attack. And it seems that those new variants targeting now specifically enterprise IoT devices and trying to turn them all the time into bots and into crypto miners. ZigBee systems becoming to be very popular within smart buildings. In a typical system, you will deploy on one side a ZigBee gateway. On the other side, you will deploy lots of smart devices that are communicating with this ZigBee gateway through the ZigBee wireless network. A very popular ZigBee system is for smart lighting. Now, our researchers found out a few months ago that it is quite easy to hack into such a system. You can simulate a ZigBee device from your laptop to get access to this ZigBee gateway, install inside a malware, and take control over this gateway. Now, think about the next scenario. You can sit in the lobby of a large bank. The only thing you need to make sure is that you will be in the range of the ZigBee wireless network, and now you can hack into the system and, for example, maybe turn off all the lights in the entire building, or maybe through the system to get into other systems inside the bank's network. This is a very popular medical device, an infusion pump that you will find in any hospital today. In most of the hospitals, you will find hundreds of this type of device. In this case, it's Alaris model from a company called BD. One of the parties that we are working with found out that it is quite easy to hack into this infusion pump. You can do it remotely through a web interface and manipulate this infusion pump to change the dose that this pump is injecting to a patient. And think about it, actually you can kill him by doing so. And the thing is that the monitor of this infusion pump will show that everything is normal. In case you are not familiar with Triton Malware, this malware targeting specifically industrial safety systems that are very popular in factories, in plants. This malware, it's first discovered a few years ago in a Saudi Arabian petrochemical company, and actually it forced the plant to shut down the entire production. But since then, we keep seeing almost every month new variants of this malware targeting now specifically those industrial devices. Now, those are only a few examples out of many, and I can share with you many interesting and crazy stories that I'm facing on a daily basis working with our customers. The question is, okay, so what now? What should we do? You have a huge number of IoT devices inside your network. Those devices are very easy to hack into, and those devices are unmanaged devices. And when our team sat down in order to solve this problem, we first defined two mandatory security functions that we would like to achieve. The first security function is to prevent unauthorized access and malicious intents from reaching those IoT devices. In simple words, if a user tries to communicate with an IoT device but is not authorized, we should block this communication. If a user or maybe other system tries to communicate with an IoT device using the wrong protocol or the wrong application, we should block this communication. And if malicious traffic tries to reach an IoT device, we should block it before it reaching the device itself. The second security function is based on the fact that already today you have a huge number of IoT devices inside your network. And it might be that some of those devices are already infected devices. Actually, a few months ago, we released to the market our new Infinity SOC solution. And we've deployed it within hundreds of sites of our customers. And we keep finding IoT devices, security cameras that are already infected by Mirai Attack. So we would like to identify those devices. We would like to identify the infected devices and to isolate them, to prevent them from compromising other devices and network elements. And we are doing so using Checkpoint IoT Protect solution. This solution will enable you to protect any IoT device inside your network and to protect your network from any IoT-related attack. The solution consists of three elements. The first element is IoT discovery and risk analysis. We need to start by finding all the IoT devices inside your network. We need to find the IPTVs and the printers and the surveillance cameras and the MRI machines and the industrial devices. Find all of those devices, classify them, map the connections between the different devices, and also analyze the risk that those devices pose inside your network. So it is about providing a full intelligent map of all the IoT devices that you have inside the network. The second element is zero trust segmentation. Zero trust because you cannot trust those IoT devices. You cannot trust the surveillance camera, you cannot trust the printer, and definitely you cannot trust the IPTV that is also connected to the external internet. So we need to apply a granular policy that will tell exactly what those devices can do and cannot do inside your network, what IoT traffic we should allow and what IoT traffic we should block. And the third element is IoT threat prevention. We should be able to identify and block IoT malicious traffic, and we should do that at several layers. At the perimeter, before it is entering the network itself. Inside the network, prevent lateral movement between the different IoT devices, and also inside the IoT devices themselves, we can protect them from the inside using our new and very innovative Nano Agent technology. So we need to start by finding all the IoT devices inside the network. And in order to do so, we are using a unique API that we've developed that enables us to collect any type of information from any discovery engine in the market. And you can see here a list of the IoT Discovery Engine vendors that we are already working with. We have a full integration with all of those vendors. And with some of them, we also take it to a strategic partnership, meaning that you can find those discovery engines on Check Point catalog, getting everything from a single provider. Now, using the discovery engine, we can identify all the IoT devices inside the network. The discovery engine monitors the traffic using deep packet inspection technology, and through the traffic, it can find all the devices inside the network and to provide you granular information about the device. For example, this is an IP camera, this is the vendor, this is the operating system, and so on. We're also analyzing the risk that this device poses inside the network, and we are doing so based on different risk indicators. Those indicators can be related, for example, to the known vulnerabilities of the operating system of this device. Let's say that this device is based on unpatched Windows 7, so we know it's have a blue chip vulnerability. So we take in all of those risk indicators, analyzing them, and give the device a risk score. It can be low, medium, high, or even critical risk. We're also providing you an online firmware analyzer tool. This is a great tool, and you can use it to upload different firmwares of different IoT devices, and we will analyze this firmware and will send you back a detailed risk report that tells you exactly what risks this firmware might pose inside your network. So you can make better decisions when purchasing new IoT devices, or maybe when replacing the existing devices inside your network. So now that we've created a full intelligent map for all the IoT devices that you have inside the network, we need to turn it into a suitable policy. And in order to do so, we're using Check Point Security Management System. Inside our security management system, we are using a component called Iot Controller. This component collects all the information from the discovery engine and enables you to configure security rules based on the IoT device's attributes. So we can refer, for example, to the device type or to the device manufacturer, and you can create one policy for all the security cameras inside your network and another security policy for all the printers. Now, one of the powerful services that we are using as part of our security management system is our application control. This is definitely the broadest application control in the market today. Inside, we support in more than 1,600 different IoT, OT, and medical applications, protocols, and commands. And this combination between the application control, the security management system, the access control, policy management tool, and the discovery engine enable us to configure perfectly security rules for each of the IoT devices inside your network. And you can see here a great example. I would like all the IP cameras to be able to communicate with the VMS, with the video management server, only if they're using OnVIF protocol. Or for example, only the Hikvision cameras, the Hikvision is the vendor, can communicate with hikvisions.update.com only if they're using HTTPS protocol. Another very common security rule that we are using is for the printers. We would like all the printers to be able to communicate with the print server. Now, it doesn't matter if you will connect new printers to the network. We will automatically identify this device as a printer, and this rule will immediately apply on this device, on this new printer. And you can see here another great example referring to the physical location of the device inside your network. So in this case, all the printers in the lobby of the building can communicate with Google Cloud Print Service only if they're using Google authorized print service application. Now, this is really great. So you can configure now perfectly security rules for every IoT and OT device inside your network. But actually, we've created a new challenge. And this is, who is going to do that? because we are talking about hundreds and sometimes even thousands of security rules that need to be configured. And this is why we've also created an automated policy builder. We're collecting information from multiple resources, such as other customers who might be using the same IoT devices like you do, so we can learn from their policies. We're analyzing the traffic inside the network, and we're also creating a huge database with predefined policies, blueprints for all of those IoT devices. So we can collect all of this information, analyze it, and generate a perfectly suited policy for each of the IoT devices. So not only that we identify the IoT devices, we're also providing you a suitable policy for those devices. Now, one of the bigger challenges with IoT devices is that many of those devices are unpatched devices, meaning that the situation might be that you have a device inside your network with a known vulnerability, with a known security flaw, and the vendor of this device have even released a fix, a software update, and asking you to go and fix or change the software inside of this device, but you cannot do that. As I said, there are many operational limitations. It could be a physical access or devices that need to work 24/7 and so on. But we can overcome it with a virtual patching service. Inside our security gateways, as part of the IPS engine, we analyzing the traffic in real time. And using deep packet inspection technology, we can identify attack patterns that are related to this known vulnerability. And in case that we will find such, of course, that we will block this traffic. And we have thousands of protections for different IoT devices and relevant operating systems. And of course, that it is automatically and continuously being updated through our Threat Cloud service, making sure you will always have the latest available protections to protect your network for those known vulnerabilities. And you can see here a very good example. Hikvision DVR devices are very popular or common devices inside enterprise networks. Those devices are being used to record video streams from the different surveillance cameras inside the network. And there are known vulnerabilities inside those devices that enables the attackers to get access to those video streams. But if you will activate the relevant protection inside our security gateway, we will identify such an attempt, and of course that we will block it. Now, looking into the IoT devices themselves, we can also protect those devices from the inside using our very innovative and new technology, the Nano Agent. A very small software component is being deployed inside the IoT device itself, and we are already working with leading manufacturers in order to support that. And this very small software component inside the IoT device automatically communicates with our Infinity Next security cloud service in order to analyze the device, to analyze the firmware, to look for different threats inside the device itself. So we can, for example, analyze the CPU behavior, the memory behavior, and so on. And in case we will identify threats, of course, that we will block them, and everything will be done without disrupting the normal operation of this device. So now that we've created a perfectly suited policy for all the devices inside your network, we need to apply this policy. And in order to do that, we're using security controls, and those are the checkpoint security controls. And we have a very wide range of security controls, also known as security gateways. We have a branch office gateways that can be used in far locations, remote locations, small offices. We have, of course, our data centers, gateways. Those can be used in the data centers also to protect the perimeter itself. We need to remember that most of the IoT traffic goes between the IoT devices and the servers in the data center and the network. We have our latest released ruggedized gateway. It's the model is 1570R. It's perfectly suited for harsh environment. It can be electrical companies or gas companies. We have support for a cloud in case you would like to use firewall as a service through our CloudGuard Connect solution, or it can be the Nano Agents themselves inside the IoT devices. So we need to take into consideration another very important thing, and this is that it's not only about the IoT devices themselves. We need to look on the entire ecosystem, on the entire network. And try and think about the next scenario. You have all of those IoT devices inside the network, but you also have workstations, servers, user, mobile access, web access, and everything is related to those IoT devices. Let's say that you've deployed the best security to protect those IoT devices, but what will happen if a workstation that is communicating with one of those devices have been compromised by a malware because the user at this workstation have opened a malicious email? Or what will happen if a user who is communicating with one of those devices will do that through insecure mobile device or insecure connection? And this is why we must adopt a consolidated security approach. And this is exactly what we are providing you with Check Point Infinity Security Architecture. This is a consolidated security architecture that covers all the elements inside the network. The network itself, of course, the cloud devices, the mobile, and now the IoT devices as well. Everything is being covered under one and unified security architecture that is being managed through a unified management system. And by doing so, you will benefit from more than 60 different security services that will provide you the best protection against known and unknown threats. So this is what I would like you to remember. The IoT devices, they're really great from one side, and we can talk about increasing the operational efficiency or moving to the digital world and so on. But on the other side, we need to remember that those devices bring with them lots of security risks into your network. And the best way to address those security risks will be based on three components or three pillars. And these are the IoT discovery and risk analysis. You need to start by finding all of those devices and analyze the risk that they are poses inside your network. Zero trust segmentation, applying a granular policy that is perfectly suited for each of the IoT devices, and we need to think about automation, how to do it automatically, and IoT threat prevention. Protect the network itself, protect the perimeter, and protect the IoT devices themselves using the relevant security controls. Thank you very much. It was a pleasure.